Hello, science fans. Have you ever wondered where the energy that powers our cars and lights our homes comes from? It's an amazing story that started millions of years ago, way before humans, even before the dinosaurs. Picture our planet a long, long time ago. The world was warm and wet, covered in vast swamps and shallow oceans teeming with life. Tiny plants and animals like algae and plankton floated in the water. On land, giant ferns and massive trees grew tall, soaking up sunlight. They were all capturing the sun's energy, just like plants do today. It was a world buzzing with life, a giant solar-powered factory. When these ancient plants and animals died, they didn't just disappear. In the oceans, their tiny bodies sank to the bottom, forming thick layers of organic material. On land, massive plants fell into the swampy ground. Over time, layers of sand, silt, and rock piled on top of them like a giant heavy blanket. This blanket got thicker and heavier over millions of years. The pressure from all those layers above was immense, and the heat from deep within the earth started to cook this buried organic goo. It was a slow, natural process, a recipe that took eons to perfect. This incredible pressure and heat worked like a super powerful oven. It transformed the buried plants and animals into substances packed with energy. The energy they had stored from the sun millions of years ago was locked inside. These substances are what we call fossil fuels. The word fossil is a clue. It means they come from the remains of ancient life. So when you turn on a light switch or ride in a car, you are using ancient sunshine, captured by life that existed long before our time. It's a direct connection to the Earth's very distant past, a kind of time travel for energy. Think about it this way, the energy in a lump of coal could have once been sunlight that helped a giant fern grow in a swamp 300 million years ago. The gasoline in a car might have started as tiny marine creatures that lived when dinosaurs roamed the Earth. This whole process shows how interconnected our planet's systems are, from the sun to ancient life to the energy we use today. We are literally burning the remnants of a lost world to power our modern one. It's a powerful idea, and it's all based on some very cool geology and chemistry. Fossil fuels aren't all the same. They come in three main types, or friends as I like to call them: coal, oil, and natural gas. Each one formed a little differently and has its own special properties. The first one is coal, which is a solid black or brownish-black rock. Coal comes mostly from the remains of giant land plants, like those ferns and trees from the ancient swamps. When these plants were buried under layers of rock and dirt, the pressure squeezed all the water out and concentrated the carbon, creating the hard, energy-rich substance we know as coal. It's been used for centuries to heat homes and, more recently, to generate a lot of our electricity. Next up is crude oil, which is a thick, dark liquid. You might know it as petroleum. Oil was formed from the remains of tiny marine organisms like algae and zooplankton that lived in ancient oceans and lakes. When they were buried under sediment on the seabed, the heat and pressure turned them into this liquid goo. Oil is incredibly versatile. We refine it to make gasoline for cars, diesel for trucks, and jet fuel for airplanes. It's also a key ingredient in making plastics, medicines, and even crayons. Countries like Nigeria in Africa are famous for their large reserves of crude oil. The third friend is natural gas. As its name suggests, it's a gas. It's mostly made of a gas called methane. Natural gas was often formed alongside oil from the same tiny marine creatures. As the organic material was cooked deep underground, some of it turned into liquid oil, and some of it turned into a lighter gas. Because it's a gas, it can be found trapped in pockets above oil deposits or within the tiny pores of rock formations. We use natural gas for heating our homes, cooking our food on gas stoves, and generating electricity. It's considered cleaner burning than coal or oil because it produces less air pollution. So you have the solid coal, the liquid oil, and the gas, natural gas. Each one is a product of a specific type of ancient life and a unique geological cooking process. From the massive forests of the Carboniferous period that gave us coal to the bustling ancient oceans that gave us oil and gas, these fuels are a testament to the planet's long and dynamic history. Understanding the differences between them helps us see how we've built our world around their unique characteristics and why they are found in different parts of the globe. So how do we get these fossil fuels out of the ground? It's like a giant treasure hunt, but instead of a map with an X, scientists use advanced technology. The first step is called exploration. Geologists use special tools like seismic surveys which send sound waves deep into the ground. These waves bounce back, and computers analyze the echoes to create a three-dimensional map of the rock layers below. This map can show them the kinds of rock formations where oil and gas might be trapped. It's a high-tech way of seeing underground without ever digging a hole, helping to pinpoint the most promising spots. Once a promising spot is found, the next step is drilling. A tall structure called a drilling rig is set up to drill a deep hole, known as a well, down into the rock. This can be thousands of meters deep. As the drill goes down, engineers test the rock samples to confirm if oil or gas is actually there. If they strike it rich, they move to the next phase development. This involves drilling more wells to understand how big the oil or gas field is. They build the necessary equipment, like pipelines and processing facilities, to get the fuel ready to be moved. It's a huge engineering project that can take years to complete. After development, we get to the production phase. This is the long-term process of pumping the oil or gas out of the ground and sending it off to be used. Think of it like a giant straw sucking the fuel from its underground reservoir. Engineers constantly monitor the wells to keep them running safely and efficiently. This can go on for decades. But what happens when the well runs dry? That's the final stage: decommissioning. The well is safely plugged and sealed, and the company works to clean up the site and restore the land as much as possible. A bit like cleaning up after a big party is over. Now, sometimes the treasure isn't in a big, easy-to-reach pool. This is where unconventional extraction comes in. Conventional methods get oil and gas that flow easily from porous rocks, but unconventional methods like hydraulic fracking in the USA, are used to get fuel trapped in tight shale rock. They pump high-pressure water, sand, and chemicals to crack the rock and release the gas. In Canada, they mine oil sands, which are sand and clay saturated with a thick form of oil called bitumen. They use hot water to separate the oil from the sand. These methods use different technologies to unlock energy from much more challenging sources. Why is all this information about fossil fuels so important? Because energy is at the center of everything we do. It powers our hospitals, grows our food, connects us through the internet, and moves us around the world. For more than a century, fossil fuels have been the main engine of this progress, providing a dense and reliable source of power. Knowing where this energy comes from, the incredible journey from ancient sunlight to the fuel in our tanks, helps us appreciate the resources we depend on every single day. It's not magic, it's science, geology, and engineering all working together. Understanding the process also helps us see the challenges. Extracting fossil fuels is a complex and expensive operation that carries environmental risks. From land use during drilling to the potential for spills, we have to be smart and careful. Furthermore, when we burn fossil fuels, they release greenhouse gases like carbon dioxide into the atmosphere. Scientists have shown that these gases are trapping heat and causing our planet's climate to change. This is a huge challenge, perhaps the biggest one our species has ever faced. Knowing this connection is the first step toward finding solutions. This knowledge empowers us to make smarter choices. When we understand the pros and cons of fossil fuels, we can have better conversations about our energy future. We can see why scientists and engineers are working so hard to develop alternative energy sources, like solar, wind, and geothermal power. These renewable sources don't run out and don't produce the same harmful greenhouse gases. The goal is to build a future energy system that is sustainable, meaning it can meet our needs today without compromising the ability of future generations to meet their own needs. Ultimately, being informed about fossil fuels isn't just for scientists, it's for everyone. It helps us understand the news, make decisions as consumers, and participate as citizens in conversations about how we should power our world. The story of fossil fuels is the story of our modern civilization, but it doesn't have to be the only story for our future. By combining our knowledge of the past with our innovation for the future, we can work towards a cleaner, healthier, and more sustainable planet for all. Consider the science.